The topic today is SIS commissioning and digitalization, digitalization of the commissioning process. And I'm going to talk about how to do this using Open-PHA checklists to ease execution and management of the commissioning process. The commissioning process, even to this day, the state of the art is really not that state of the art. The state of the art hasn't changed essentially since I first did commissioning. So commissioning is something that's near and dear to my heart because coming out of college, I got a chemical engineering degree from Ohio State, and then immediately went to a company called UOP. Some of you might be familiar with them. They are an oil refinery process licensor. And my responsibility is that I was an instrumentation and control field advisor. So what does that mean? That means that people in the office who have experience and know what they're doing would write specifications for what the instrumentation's supposed to do. And then I would grab a pile of specs and a pile of drawings and a pile of standard worksheets and get on a plane and fly to wherever they built the plant and make sure that what was installed is what was specified. And that's kind of the beginning and like one of the most important parts of commissioning. And the way that we did it back then is pretty much still the way that we do it today. And that really needs to change. It's good. There's a lot of efficiency to be gained in digitalizing the commissioning process, and that's what I want to talk to. All right, so what is commissioning? Commissioning is the definition from just a plain old English dictionary is going to be to bring something newly produced, such as a factory or a machine, into working condition. So bring into working condition. I installed it, it's not on, and I'm going to turn it on and make sure it works. Now, with respect to safety instrumented systems, which is kind of one of our core activities here at Kenexis, we're going to be following the rules of commissioning in accordance with the IEC 61511 standard. So here in the top drawer of my work shelf, I have the IEC 61511. It's never very far away from me. And if you go into clause 14, you're going to see all the rules for commissioning. So clause 14 in the copy that I have is on page 69. I've got the official IEC edition here. All right, so if you look at the standard, now I'm not going to look directly at the standard itself. I'm going to kind of go off of my notes here on the slides. The objectives is 14.1. It says the objectives of commissioning are to install the SIS according to specifications and drawings. So there are specifications, there are drawings that define what the instrument is supposed to do, how it's supposed to be installed. That's something that some of that information is in the safety requirements specification package, but it's going to be bigger than that. You need a lot more information. I'll get into what that is in just a second. Also, to commission the SIS so that it's ready for final system validation. So we're going to make sure that we got what was supposed to be installed was installed and it was installed correctly. Then we're going to power it up, turn it on, and make sure that it's connected properly. That's what we're doing with commissioning. Okay, the requirements. So in the standard, clause 14.2 says you need to have a written plan for how you're going to do this. Okay. State of the art for a written plan is a little bit sketchy. I'll show you where we're going with that. But that plan needs to contain a list of what the commissioning activities are. It's going to need to include procedures that you're going to use to perform the commissioning. The measures meaning what are the targets, what are the objectives that we're trying to achieve, and then the techniques that we're going to use to perform the commissioning. The plan also needs to have a schedule of activities and for people that are responsible for getting the activities done. And then there's also another subclause that says you could take all of this and integrate it into an overall project plan. There's no need for an independent plan just for commission. Okay, so those are the requirements. 14.2.1 says you need to have a plan. Well, what does that plan look like? And this is the state of the art that I'm going to show you. A traditional plan looks like this. And you're saying, well, Ed, you just have a box. And yeah, it usually is a box full of folders. This is the state of the art. So my commissioning plan is I'm going to do this work. Well, what is this work? Well, you're going to have a list of folders, and there's going to be one folder for each loop. And we're going to do this one at a time. So my work schedule basically is, here are all the loops that I need to do. I'm going to pull the folder out of the top, and I'm going to execute that. So this is kind of like my list of what needs to be done. Okay, so I've got kind of, a list of where I need to be. And some of the other stuff is in here. So when we talked about planning, it says, what are the activities? What are the procedures? What is the schedule? Who are the personnel responsible? The schedule and personnel responsible gets a little bit tricky because generally, you're going to have a project manager who's going to say, okay, these are my instrument techs. You do these loops today, you do those loops today is a very common way to do things. But now in terms of procedures, let me open up this folder a little bit. And one of the things that you're going to see at the top of the folder, and if you can't read this, don't worry about it, because when I show you the better way to do this, it'll all become clear. You're going to end up with a procedure that looks like this, that is going to tell you on a loop-by-loop basis what you're doing. So it's going to start with the question of, is all the documentation for the loop available and correct? Then, does the tag number on the device agree with the tag number on the PID? So basically, you have a procedure where you're going step by step by step to inspect and commission the device of interest. So this is our procedure, this is our scheduling, and then there's going to be other additional information in this folder, which I will get into on the next slide. So let me go ahead and share my screen again and maximize my PowerPoint slide. So my plan is my pile of folders, but each folder is going to contain all the information that you need for a loop. So 14.2.2, the next clause says that all SIS devices shall be properly installed according to the design and installation plans. So again, back in my days at UOP, I would go out in the field and I would check. Now, for each loop, you're going to need a good amount of information in order to make sure that you're going to be able to do things properly. So first one is going to be the instrumentation spec sheet. And I'll show you these in a little bit more detail in just a second. So I've got my data sheet. This is the spec sheet. This is how the instrument was designed and purchased. So I'm going to check this spec sheet to make sure everything on here is true. I have my SRS instrument sheet, and I'm going to check and make sure that everything on here is true. I have my piping and instrumentation diagram that contains that instrument to see where it's located and other relevant information. And then I am also going to have a loop sheet like right here to make sure that all of the wiring details are correct, the wires are landed in the right locations. So between all of this documentation, I should fully understand what's supposed to be out in the field, how it's supposed to be installed and configured. And then I have, again, my procedure, my checklist that tells me what steps I need to do, and a place to kind of mark off on things to say, yeah, everything's good, everything's correct. The last item is an installation detail. So for installation details, I still have the Holy Bible of engineering. This is from UOP. You can see I still, you probably can't see, I still have my business card from when I was a UOP field advisor in here. And basically every bit of information related to instrumentation and control that I would need while I was out in the middle of nowhere doing these commissioning activities. In particular, we have installation details. So if you look at these installation details, they're basically isometric drawings that explain which connections are supposed to be connected where, how is the device supposed to be oriented, what needs to be free draining, what needs to be run to a process drain, where do I have isolation valves, and so on. So for this device is LT101B, I have all my details for how this thing should be connected. So now I have all my documentation and I'm ready to do my checkout. And I do my checkout and verify that everything that was spec'd is correct. And that's how it's working out in the field. Okay, the next thing I'm going to do, clause 14.2.3, is the commissioning. Basically, commissioning is a list of activities that when you're done with the commissioning activities, the device will be in operation and communicating with everything that it needs to communicate with. We're going to start out with the grounding. So you need to make sure that all of your devices are grounded, because if devices aren't properly grounded, they're going to have all kinds of erroneous signal problems. You do your grounding with your loop diagram. You remember that your signal wiring, let me make this a little bit bigger. So here's a kind of a typical loop sheet. Your positive and negative signal wiring are going to be inside a multi-conductor cable that has a shield around it. And you're going to want that shield connected all the way to where it is grounded. Most of the time, you're going to do your grounding at a ground rail in the marshalling cabinet, either in the control room or the remote instrument enclosure, which is what's shown here. And you want to make sure that you don't ground in multiple places. So for instance, there's the possibility that you could tie off your grounding out in the field to structural steel that's been earthed, bonded and earthed. But you don't want to ground in two places, because if you ground in two places, then if the ground here by the transmitter is a different potential than the ground here in the control room, you're going to have a ground loop. You're going to, because your grounds are different potentials, you're constantly going to be throwing flowing electricity through your shield wiring, which is going to throw errors into your measurement signals. So step number one, make sure that you're grounded in the correct location. So for that loop diagram out in the field, when you look at your wiring connections in the instrument itself, your shielding should be pulled back and taped off, as opposed to being connected to a ground rail out there. But again, follow your loop sheets to determine what the designers wanted with respect to grounding. The next thing you're going to do is you're going to connect your energy sources. Pop this up. So you've run power out to the field. For most of the transmitters today, you just have a 4 to 20 loop where your power and your signal are the same sets of wires. So as soon as you connect your wiring, as long as the power supplies that supply the signal power are operational, you should have power to your instruments. But some instruments require separate dedicated power supplies. Once again, follow your loop sheets. The third item, which actually kind of blows my mind, the most common failure the most common thing that I punched out at UOP is that they didn't remove the shipping plugs. So, and they go out of their way to make them a screaming bright orange. How do you not know to remove the shipping plug? Well, people will leave the shipping plugs in. This inspection for damage actually should have happened back in 14.2.2, where we were doing the checkout. Inspection for damage is more of a checkout than a commissioning activity, but it is what it is. Next thing you need to do is a calibration or a configuration. Now, back when I was at UOP, I wasn't doing this. I was basically only doing the preliminary checkout, and the site's electricians and instrument technicians would be doing this stuff. So we're going to connect calibration tools to the devices, hand pumps, calibrated pressure gauges, so on, and set the 0, 50% in span for a 3-point calibration, or 4 or 5-point calibration, whatever your standard is as a company for doing the calibration. And that calibration needs to be done in conformance with your spec sheets, and those spec sheets should match. Let me escape out of here. The what's in the safety requirement specification. So if I pull that spec sheet back up again, you'll see that the range. Okay, so I'm showing a differential pressure type transmitter that's measuring range is 0 to 15 psi, which is actually kind of ridiculous. I put together this this spreadsheet real quickly before the training class, but you're going to have a calibrated range that you're going to be calibrating to, and accuracy, repeatability, and so on. So make sure that when you're doing your calibration, you're matching up with what it says on your spec sheets. Back here. Next up, you confirm that the device is operational. So after the calibration and configuration, you have confirmed that the device is going to work, and then we're going to want to check its connection to the logic solver. Now, one of the things that I want to bring up here is this configuration piece. This is where you need to go not only to the spec sheet, but also to the SRS. And the one area, I am pretty sure I have punched this out on every functional safety assessment I have ever done. I have seen a configuration failure. So one of the key things, configuration, if you look at a modern smart transmitter, there are probably hundreds of different parameters that you can set. It's not just the 0 and the span. You can turn on and off heart communication. You could turn on and off different error modes. Well, one of the configurations that's really important for safety instrumented systems is what is the instrument's response to a detected failure. So if this level transmitter self-diagnoses that it's in the failed state, what should happen? And some of the configuration options might be that you will go off scale high, you will go off scale low, you will hold the last good measurement. There are a lot of different things that you can do, and those things should be specified in your SRS datasheet for this device, and it might also be specified in the general instrumentation spec. And I say that this is the most common thing that I punch out because this is what happens when I'm doing a functional safety assessment or an audit on commissioning. I ask, okay, so for this device, did you check the configuration of the failure mode? And they're like, I'm not sure what you're talking about. And I say, okay, well, if this device self-detects that a failure has occurred, what output will the transmitter give you? And the answer almost universally is, okay, well, we're using vendor XYZ. Do you know what happens by default? Yes. So most people still have whatever the default setting is what it is when it was installed in the field. So that's something that you're going to want to check. It's not just an outside visual inspection. You're going to want to plug your HART communicator in, check the parameters against the spec sheets to make sure that everything on the spec sheets is true. Okay, so kind of going down the road, the next thing is in the configuration process is logic and I/O are operational. So you know that the device is working based on your calibration device. You hook the fluke up to it and everything checks out. But you also need to make sure that that signal travels to the right location and that the receivers are programmed properly. So you're going to want to go and make sure that the logic solver is operational and the I/O is operational by going into the maintenance and engineering interface. And when you're manipulating the sensor, you're going to want to look at what the signal is in the maintenance and engineering interface to make sure that the logic solver is correctly reading it. So in order to do that, let me bring that loop sheet back up. You'll see that in this case, this level transmitter is wired into rack 1, slot 3, channel 1, and it's connected to an analog input card. Okay, so you know where the wires are supposed to land, and you know which element in the PLC is supposed to be receiving the signal. You're just checking to make sure that what the transmitter is sending is showing up in the correct place in the logic solver. But we don't stop at the logic solver. We're going to continue to make sure, bear with me, that all of the interfaces are operational. Nobody is using the maintenance and engineering interface during the actual operation of the plant. They're using an operator interface, or maybe even one of many operator interfaces, because it's currently in vogue to have a dedicated operator interface for the SIS, along with that information being mimicked in the DCS operator interface. Of course, you might just have bells and switches and lights and bells telling you what's going on. So you're going to want to chase that signal from the sensor all the way out to every last display device to make sure that the interfaces are working, the communications are working, everything's been properly configured to show the right signal at the right location. Once you get to that point, if you've successfully made your way through it, you will sign off on the loop and say that, okay, this one has been installed and commissioned. The process is generally called buying a loop, because that's generally the point in time where the operating company takes possession of that loop from the installation company or the engineering company that built it and provided it. Okay, so that's the commissioning step. Once the commissioning step is done, well, actually, during the commissioning, there are a couple of other items that you need to be concerned with. So there is 14.2.5 in the standard talks about nonconformances. So nonconformance, let me just read the clause. Where it has been established, the actual installation does not conform to the design, there are things you need to do. You need to evaluate the discrepancy and then make a determination. Does it impact the intended outcome? So for instance, if we specified that you use a Rosemount 3051, but you installed a Yokogawa EJX, maybe that's okay. So you need to look at the design of the Yokogawa transmitter to determine whether it performs an equivalent set of functions. If it does, if you determine, okay, this is okay, we were expecting X, but we got Y, I analyzed Y and Y is okay, you're not done. You're going to need to as-built all of your documentation. So, everything from the loop sheet will have make and model, the spec sheet will have make and model, the SRS spec sheet will have make and model. You probably have changed your SIL verification calculations and you're going to need to get them rerun. So as-builting is something that generally isn't going to occur on the fly. You're going to do that. You're going to kind of redline your drawings, redline your reporting, and then fix it generally after the plant is up and running, or any delays in getting to startup will give you the opportunity to as-built those designs. Now, if the impact is severe, then you're going to want to repair it. So here I was talking about using a differential pressure transmitter. Well, in a differential pressure transmitter, the top is the low pressure and the bottom is the high pressure. But if you took your tubing and you switched what was supposed to be high pressure and what was supposed to be low pressure, that's no good. We can't accept this. We can't as-built it. We're going to need to send somebody out in the field to switch the taps the way that they should have been overall. All right, so now how does that happen if something got messed up? So I'm going along in my folder. I'm on, let's see here. It will be item. Let me get my pen because now I need a physical pen. And I'm on, let's say, the item, have instrument impulse lines been connected to the right ports? So I'm going to have to say no, they haven't. So no action item. So I go say no, and then over on the action item, I'm going to say switch taps. And under notes and details, I can say something like the taps were switched. Okay, I would elaborate a little bit more if I were actually out in the field. So now I have on my report, I've got a no right here, and I've got an action item that needs to get taken care of. So there's a management issue that we're going to need to get into to make sure that these action items get resolved before the plant gets put into operation. How do you do that? Well, let me show you the state of the art. Are you ready for this? A red sticker. So I'm going to go into my pile of stickers, and I'm going to take this red sticker and I'm going to put it on my folder, and that tells me that this is bad. And I'm going to take this folder and I'm going to put it in the pile that needs rework. But maybe for shutdown valve 101, everything checked out on the first try. So I'm going to use my super high-tech green sticker. And I'm going to pull my green sticker off of my pile. And boom, this has been checked out. So now I have 3 piles. I've got my starting point. I haven't done these yet. I have my green pile, which means I checked them out and they're good. And I have my red sticker pile, which says I need to do something. And basically the project isn't done until all of the folders are in the green pile. So the starting point is empty and all the red stickers have been repaired. And after they're repaired, you take your green sticker, put it on top of your red sticker, and now we're good to go. Super, super high tech. All right. What I showed you was the mechanism of writing down what the problem is in the worksheet. Also, when I was at UOP, I would do dedicated punch lists. So instead of just leaving that information in each individual folder, I'd have a separate kind of report where I concatenated, brought together all of the things that needed to be redone and put them in a single report. So that report is properly called a deviation record, but in the colloquial oil business, we just said it's the punch list. Okay, so we need to resolve all the punch list items with the team, and this would happen during the morning meeting. I would be checking stuff out all day, and then the next morning I would hand out a punch list and say, these are the devices I checked, these are the problems that I found, somebody needs to go out and fix them. Also, there are red lines that need to be done, and it's now you go back into your documentation and you redline stuff to make sure that it's so that you know what it's supposed to be when you have time to fix them. Okay, shouldn't have done that. The next clause, I'm going to go backwards. So this was 14.2.5 that talks about dealing with nonconformances. 14.2.4 talks about appropriate records of commissioning of the SIS shall be produced. So commissioning records need to be created. I need documentation, and I'm going to use that term loosely. I need documentation that every loop was commissioned. That documentation needs to include the results. What did I check? What values did I see? Were the objectives in my criteria met? Were there failures? And if there were failures, why did the failure occur? What was done to resolve it? Often, I mean, as you see here, I'm going to have a pile of folders in a box. This is my commissioning record. This is the state of the art. Well, no, this is where we have made just a scotch, just a tinge of progress in that after commissioning is done, someone is going to grab this folder, they're going to stick it into some sort of document scanner, and they're going to scan it to PDF. So now our state of the art is we're not going to keep all of this paper because paper gets old, it gets stinky. Eventually it crumbles and you can't read it anymore. So we're going to digitalize by creating PDFs of our paper document. Okay, well, that is the state of the art. It does meet the requirements of the standard. And I would say for most of the functional safety assessments and audits that I've been involved in myself, that's generally what I see. I see a PDF of the loop folder. So there'll be literally a folder for a loop with all the scanned documents that were the result of that loop. Okay. So that is the state of the art. That's how we do things now, but we can do better. There are online databases. So in the future, why are we printing paper? We have devices like our smartphones, our smart tablets. These phones and tablets can usually be taken out into the field. You can get intrinsically safe versions. There is one operating company that shall remain nameless that does everything on iPhones because even though an iPhone is not certified to be intrinsically safe, this operating company, and they're a big operating company, did their own testing to show that a certain model of iPhone in a certain case will not generate a spark that's capable of igniting a gas cloud. But that's just one operating company. Take that with a grain of salt. You can buy IS versions, definitely of like Android devices and Windows devices. So what we want to do is we want to replace this box of folders with a software tool. That software tool will work best if it's an enterprise software tool where I have multiple users and multiple sites being able to access the tool simultaneously, so the entire work group can always be on the same page. It's a central repository that's used by many people, and then this tool will actually help to facilitate project management because the computer can do automatic calculations to determine what percentage completion are you? Who is supposed to be doing what and when? So there are actually at least three tools that we have in the Kenexis Integrated Safety Suite that can do this. OpScope is our online procedure tool, which is probably overkill, but it can do it. We have Open Audit and we have Open-PHA. So I'm going to show you how to do everything that's in this box way better using the Open-PHA software tool. And basically what we're doing is we're going to configure Open-PHA for checklists. I know you're thinking Open-PHA, isn't that a HAZOP tool? Yeah, it is. But it's got HAZOPs, it's got LOPA, it's got checklists, all variety of PHA, and you can use the checklist as your procedure for your commissioning. I will show you all this in just a second. Now, another reason that I wanted to show you this in Open-PHA is that the enterprise version, and I'll show you how to leverage the enterprise features, is very inexpensive in comparison to our competitors, but we also have a free desktop version. So if for an individual technician that doesn't need to have their results communicated in real time, you can go ahead and just use the free version of the software. Okay, so first part of what we were doing is the planning. So in the planning, you need to have procedures, you need to have measures, you need to have techniques. So what I'm going to do is I'm going to open up Open-PHA. I'm going to open up KISS here in just a second. And I'm going to show you that when you're doing commissioning, you can do all of your commissioning with, well, maybe with one product, depending on how much digital information, how much you want to ease your digital information. But I'm also going to refer to our Vertigo product too, which is our SIS design basis software, so that we don't have to make multiple copies of the same information. Okay, so we're going to talk about checklists. We're going to talk about checklist categories and planning. So let me go. I'm going to open up a web browser because Kenexis Integrated Safety Suite lives in the cloud. Well, this version lives in the cloud. I could also show you the desktop version, which is available on Mac, which is what I'm using right now, Windows and Linux. So I'm going to go and I'm going to click. It's the URL is kiss.kenexis.com. And most of you know that you can either log in with a username or password, or we also do a single sign-on. So I'm going to sign on with Microsoft because that's what Kenexis does. And I get into the project manager portion. Actually, let me make the screen a little bit bigger so it's easier to see things. I'm going to go to General Oil and Gas Operating Company, which is the fictitious company that we created for training classes and software demos. In the General Oil and Gas Operating Company, I'm going to go to the Texas City Gas Plant. I'm going to go to the separations area, and then you'll see that in the separations area, I have a Vertigo study that contains the SIS design basis. And then I have this other folder that I'm going to call commissioning. And in the commissioning folder, you'll see that I have an Open-PHA file called separations area SIS commissioning. Okay, so once you open up a new file, you put in the information about the facility. And then you're going to put together your procedure. So I've customized this page to not show you all the other HAZOP stuff. I'm only going to show you checklists. So you begin by creating a list of all of the loops that you're going to use. So now what you could do is I can do everything kind of raw from scratch. So I could say pressure transmitter 300 is the pressure transmitter, and that's my list of checklists, and then I could go to the checklist details and I could start putting in checklist questions like check the instrument tag, learn to type, to make sure it matches the P and ID. This is possible, and you might want to do this once. Once you have it done, you have other options. So the other option would be is if you have a, let me create a space here. If you have a checklist you like, so for level transmitter 101B, I have a checklist that I like that's blank, and I'm going to simply go to the copy button. When I pasted, you'll see that it brought all 28 of the questions. So in Open-PHA, there's concepts of a deep copy and a surface copy. So when you see the blue, that means you're on the cell and it's going to copy everything in the entire row. Whereas when you click into it and you just have that blue shaded outline, you're only going to copy the text that is in that cell. So the ability to copy the row and all the children of the row, or just the text that's in the box, is a thing that we could do. So if you have a checklist you like and you have a template, you can copy paste. The other thing that you could do, which is going to make your life a little bit easier, is I can come down here and I could create a new row, and then this is a premium feature that's only available in the web-based version of the software. But in the premium tools, I can say import from library, import a checklist, and then in the Kenexis standard library, which everyone that uses our software has access to, there's a checklist called Instrument Commissioning Checklist, and I can click on the button to import checklist, and you'll see that it imported the entire checklist, including all the questions, from the library. So that's a checklist that's in the Kenexis library that's available to everyone. Also, for your individual operating company, you can create your own custom checklist for your own facility. So in the premium tools where I showed you Kenexis standard, if you have a custom library for GoGoCo, might have their own custom library, it would show up here and you can import checklists out of your own custom library. Okay, so this is basically the procedure. This is the plan. So these are the loops that I need to check. And for each loop that I need to check, this is essentially the procedure for doing the checkout. Is the documentation available? Does the tag number match? Does the model number match the spec sheet? Is the field installation consistent with my standard installation drawing and such? These are the steps you need to perform. All right, we've kind of got a little bit of a plan, but the other portions of planning include who is doing this and what are they doing. And right out of the gate here, we're going to be already better than what we were doing with the box, because we can do some additional planning. Okay, so we talked about the activity list, which gives us our procedures, measures, and techniques, but we can also do planning in terms of schedules and personnel. So there is something called sessions, which is, like it can be a day or it can be hourly. And then we also have team members. So let me go back into the Open-PHA and go here. So I'm on the checklists tab. If I go to the study data tab, we start with the overview information, but you have all of the other stuff that you would handle for a study. So who are the team members? In this case, it would be your instrument technicians, it would be your instrument engineers, everyone who is involved in the commissioning process. So under study data, there's the team members tab where you can add all of the people who are involved in the commissioning process. Then under sessions, you can list out who is doing what. So on January 29th, there's the 12-hour shift, and you know, maybe I might even say day shift if we're doing day shift and night shift. Technician number 1 is going to do package number 1, which includes pressure transmitter 101 and pressure transmitter 102. And it's going to be Theo Oval is my instrument tech who's going to be doing that. Also on the 29th, I'm going to have Buckeye doing HV 101 and UV 103 commissioning. And on the same day, I'm going to have Myra Lake doing pressure transmitter 213 and LT 102. So this actually gives you a little bit more even than just the box of folders, because I'm making a plan of who is doing what and when they're doing it. And we can even put together a grid as the project is commencing, saying, okay, Theo did that one, Buck did this one, Myra did this one, and kind of build out kind of who did what, where we're at in the process. So planning got better using this tool. Okay, that's the purpose of this slide. Now, the next thing is kind of assistance in verification. So we need to verify our instrumentation and installation, and this is where we're going to need access to a lot of drawings. What I don't want to do is I don't want to carry a pile of drawings out to the field. I would like to be able to electronically access them. And you know, you can always use your file server, but you can use other tools to help you access the information. And that's where I would use Vertigo, where we recommend you do your SIS design. So if I escape out of here and I go back into my HAZOP software, I'm going to go, if I go into checklists, I know that I'm looking at LT101B. What I'm going to do is I'm going to open up another tab in my web browser. I'm going to connect into KISS one more time. I'm going to go into General Oil and Gas Operating Company. But now, instead of looking at the commissioning worksheets, I'm going to actually look at the design using Vertigo. So I'm going to look at the design of the plant, and I'm just going to go ahead and open up, instead of looking at the safety instrumented function list view, I'm going to shoot right to the cause and effect diagram view, because it's a little bit, actually now it's way too big. Let me make this a little bit smaller. So our cause and effect diagram view makes it a little bit easier to manipulate things. So I know, so as I go out to the field, for LT101B, it's going to say, is all documentation for the loop available and correct? And then I'm going to go here and I'm going to say, okay, LT101B, when I click here, it's going to bring up the SRS data sheet. So here you're just kind of going through your SRS data sheet to check things out and make sure that they're correct. Whatever information you filled out on the SRS data sheet. We also have the ability now to view other documents. So if I go to the view button and I go to documents, I can bring up the P&ID. So all that we have in our Vertigo software is a link to the file storage location. So at Kenexis, we store our files in SharePoint. I'm sure a lot of operating companies do the same thing. So boom, right here, right away, I have a copy of the P&ID, and I could see, okay, right there is LT101B. It's drawn as a displacer, but my spec sheet shows that it's a differential pressure. That might be something that I'm going to end up punching out. I could do similar things for that same loop sheet that we looked at earlier. Here's the loop diagram. I can also bring up the spec sheet that we looked at earlier, right there. So all that kind of information and linking is available in Vertigo, and you can simply view the drawings and go into the cause and effect diagram. It will tell you what drawings you have, where they're located, and also give you the spec sheet information out of the SRS. So everything is available digitally. So when I get here, I can say, yes, all of the documentation is available for the loop, and then I simply go through the rest of the checklist. Does the tag number on the device agree with the P&ID? I'm going to say yes. Does the model number of the device agree with the spec sheet? Yes, it does. And there, again, if I go here, I would get a model number there. There is my model number, Buckeye Instrument Displacer. Or whatever it was. So you can see that all of this is available electronically. Now, is the field installation consistent with the standard installation detail drawing? I'm going to say no. And I'm going to say the P&IDs show a displacer dial level measurement, but the installed equipment is a differential pressure transmitter. Okay, and then under checklist recommendation, where I would start here is I wouldn't say fix it. I would say evaluate LT 101B discrepancy in equipment type. So I don't know whether, maybe, hey, who knows? It's not what was on the spec sheet, but maybe a differential pressure type level measurement is just fine. And then I keep doing this for all of the items that were on the checklist, and I've got 30 some odd. So this worksheet that is kind of a typical thing is going to be set up for every instrument, and that's just kind of a boilerplate thing that we have. For your operating company, you might have different commissioning checklists depending on the type of instrument that you have. So here, there's a question that says an orifice plate is used as the primary element. Is the flow direction and the orifice bore correct? Well, this is not applicable to what we're doing here. So it's something that I would, you could just kind of throw this question out and say, well, it's not relevant to what I'm doing here. Or again, you can have your own checklists. Again, there's infinite customization that you can do. Have the impulse lines been connected to the correct ports? No. The ports of the transmitter have been switched. And here, I'm not going to create a new recommendation yet. I'm just going to leave that evaluate recommendation up there. Okay, zeroing, confirm block and bleed valves. You can see I'm going to kind of scroll here slowly and not go into detail on what all of the questions are, but we're going to be covering installation. We're going to be talking about utilities like air supply. We're going to talk about grounding. We're going to talk about confirmation of power voltages, shipping plugs. There it is. Did you remove the shipping plugs? Terminations, visual inspections of corrosion of not just the instrument itself, but conduit, tubing, piping. Did we get a loop check done? And have you successfully calibrated the device? So you kind of go through these, and whatever was a yes is a yes, and you go. until you're done. Once you get done, now we could do a little bit more management. And before I show you some of the management activities, let me go back to the PowerPoint slide again. So going back to the PowerPoint slide, I talked about verification of the instrument installation, and then I also talked about the documentation of the commissioning activities. So once again, you have a checklist of questions which forms your procedure. You're going to provide notes in the justification column. If something's wrong, you're going to need to put a recommendation out that describes what needs to be done to resolve that recommendation. And that's going to be your record of activities. Now, these records are going to be automatically recorded in the database. So as soon as you make the changes, let me go back here to my worksheet, I can hit the save button, and this study has been saved back to the server, and everyone in the company is going to be able to view it. But I can also do reporting out. So if I click here on the print tab, and let me go to my downloads and open up this worksheet. What it did was it exported to Excel. So Excel's spooling up in the background now. I'm going to open it. And now that is something that you absolutely will not be able to read. So let me explode it a little bit. So here you have the information for this checklist. If you wanted to make a printout, or if you wanted to email it to someone who doesn't have access to the online tool, you can do that. And you can report out not just the checklists themselves, but also the overall status. So if I report out the overall status, now we have our entire project plan, which is our list of loops. We know how many items were completed out of the total and a percentage. So basically at this point in time, I'm 33% done with the first instrument. But hey, this was automatically generated, and you now have more information than you ever had with your box of folders for management purposes and reporting purposes. Also, in terms of reporting, you're going to be able to go and look at your recommendation checklists. So I'll come back to this in just a second. Let me show you that PowerPoint deck again. So we're generating records. We can print them to paper if we need to, but at the end of the day, the database is there, so the documentation requirements are automatically met. Now, tracking non-conformances is another one of those critical items. And in the box method, we have kind of a stack of folders that have either a green or a red. So when specifically we're looking at the red. So when we want to look at, well, what is the scope of repair activities that we're going to need to do in order to get our plant up online and running, someone is going to have to manually dig through that red dot file, go to the pieces of paper and look at what the problems are and kind of pull them together. Well, in Open-PHA, you don't need to do that. It's automatically there. You just simply need to go and click on the recommendations tab. The recommendation tab is going to tell you what is the issue that was found, and then you can work with that issue. So let me jump back into the software. So let me get rid of these old items from a previous discussion. And this is kind of where we would start. So I have an item that says evaluate LT101D discrepancy in equipment type. I can assign this a priority. It's like, okay, that's a big deal. I want it, top of mind. I want to assign it to someone. So, I can assign it to INC group, or I can assign it to one of the specific engineers. I can track the status. So at this point in time, it's pending because nothing's been done yet. And I can put some comments in here and say, review whether a DP level measurement is acceptable. Okay. And even furthermore, we have the references. So if I'm like, well, what does this recommendation apply to? Okay, well, it showed up in 2 checklist items. I can click on the button and it's going to bring me to the page where the recommendation was generated, and it will show me what question it was, what procedure step that triggered the recommendation, and any other notes on the justification. So in terms of resolving checklist items, this approach is far superior, and it really is going to facilitate and help management to know what's wrong, what needs to get fixed in order for me to be able to start this plant. All the information is available at the dashboard level. And again, it's available to everyone in the organization, not just the technician who has the box of folders. Okay, going back to the PowerPoint deck, that was tracking non-conformances, which is greatly improved. And that's basically the big picture item. So we talked about commissioning today, but there was a big focus at the end of the discussion on digitalization of the commissioning. Why would we want to digitalize commissioning? Because number one, it makes planning easier. You know which of your resources are going to be doing which activities when. That's all in the sessions and the personnel tabs. It's going to automate many of the tasks. So basically, you can pull entire checklists out of the libraries, and you have access to all the information. So you don't need to grab a box. You don't need to print paper, put it in folders. A lot of the activity is going to be automated. And there's also, it's not available yet, but it will be in the not too distant future. If I go back here to Vertigo, Vertigo knows all of the loops that are part of this SIS. Wouldn't it be nice if I could just press a single button and generate the entire commissioning checklist with one click? That is in our software development plans. Automation makes tasks easier and quicker. Enterprise software is going to facilitate group communication. So the project manager can open up a file and know where everyone is in the process. So they'll know what degree of completion you have, who's been working on what step are they on, even is all available to the entire team that's working on the commissioning. This is going to give you superior management of execution, and that recommendations tab is going to make the resolution of the findings go faster, be more transparent, and make all of the data again available to all your team members. Now, the other beautiful thing about this format that I just presented to you is that all of this can be done in software that some of you already have. So if you already have Open-PHA Premium, it's there. All you need to do is create a worksheet. You just need to use what you already have. And if you don't have a premium version, the cloud-based version of Open-PHA, and you're kind of happy with being an island of data, you can download Open-PHA free. So all of this digitalization with all of its benefits probably going to be free for you because you're either already using Open-PHA or you can download a free version of the software. So with that, that is all that I have. Let me go ahead and open up the floor to questions if anyone has any questions. Okay, So while you're thinking of questions, if you come up with a question you want to type it in the chat, please feel free to do so. What I showed you was our Open-PHA tool. We also have a procedure management tool called OpScope that is a lot more elaborate. It's designed to write procedures and track the execution of procedures in real time with dashboards, and it includes things like being able to include training videos for how you execute certain steps in a procedure. It has GPS locations, so you know where you're supposed to go, and it'll draw you a map of how to get there. So that's another tool that's available if you want to research OpScope a little bit to see if that might be a more appropriate tool for you. It's got much more horsepower. I think I saw a question pop up, Chris.
Yeah, Mohammed raised his hand. Go ahead, Mohammed.
Yes, thank you. Thanks for the presentation. I just have a few questions regarding the practicality of using the software for commissioning large plants. For example, like thousands of loops. If you have thousands of loops, sometimes it gets very hectic, and there is a rush of time, and we need to complete as soon as possible. So I don't know if the labor or the workforce will be able to follow the system steps to commission the project in time and finish the project. And,
okay.
Yeah, thank you.
Yeah. Okay. Yeah. Let me get to that question. If you have more, you can answer. You can ask them. In your case, if we're talking about thousands of loops, you might want to, the way I had it set up is I had one file for the entire commissioning process. You might want to break it down into multiple files. So you might have one Open-PHA checklist file for each piece of equipment. And then you can kind of assign those pieces of equipment to different technicians and have them check in on a regular basis. So instead of just one study, you would have multiple studies. That's one way to do it. And again, our OpScope software it's more of a procedure management and overall tracking, and they're doing multiple activities simultaneously and having a dashboard is something that software application is capable of. But, just a couple of ideas: break it into multiple pieces and then track each piece individually and roll them up. Or again, OpScope it's not something I was prepared to talk about in this webinar, but that is an option.
And this can be used by operators, oil and gas operators?
Anyone can use it. So the way the software works in the premium cloud-based version is that basically everyone in your organization can have an account. So your administrator would define all of the people who can have an account, and for every account, you have access to how many ever licenses you have. So if, for instance, you had 10 licenses, then 10 people can use the software simultaneously. And if an 11th person tries to log in, they'll get a message saying that all of your licenses are consumed and that you're going to have to wait. So everyone that has an account will have access to the software, but we do have restrictions. So let me kind of back up a little bit here. So I'm going to leave this page. So when I go here and I go to this menu here, viewing facility properties, you'll see that different people have different access. So if I go to the root directory, these people have access to the entire directory. But if I have like the Texas City gas plant, then there's a smaller group, separations area, smaller group. So you can assign different people with different access to different folders so that the wrong people can't view or modify things that they shouldn't be viewing or modifying.
My last question is this software linked to the safety lifecycle softwares? For there are some softwares that make
Sure.
from HAZOP to cause and effect to SRS to
Absolutely. So
yeah.
in this case, so I was in here, I was in the commissioning checklist, and I have a list of instruments, but that list of instruments came from SIS Design Basis. So this is the software tool that you define what your safety functions are, and then for every individual function, you're going to be able to define what are the measurement devices, what are the logic solvers, what are the final elements, and so on for these devices. And so the full SIL verification, the full safety requirements specification, including general requirements, data sheets for pieces of equipment, cause and effect diagrams to define what the logic is. But even more so, there are linkages. So you'll see that for this interlock, USC 101A, high pressure separator closes the inlet valve, you have a linkage to the LOPA. So if I want to look at the linkage, I can click here and I could say, okay, this SIS, and this is something that I just contrived here for demonstration purposes, is connected to a LOPA study where the information came from. And you could see everything is red lighted because what is contained in the Vertigo study doesn't match the Open-PHA study. So you can make those kinds of changes, and you can synchronize things to match what the Open-PHA file is saying. So there's a way to synchronize things, and you can also click on the link and it will go and it will bring up that PHA study to explain, okay, this is the safeguard that it's connected to. This safeguard is used in these LOPA scenarios. So all of these things are linked together and connected, and the workflow flows from step to step. So you would start out with a HAZOP. In your HAZOP, if you wanted to do a LOPA, you would say, yes, I need to do a LOPA because the consequence is higher for whatever reason. You pull up the LOPA worksheet to bring the layer of protection analysis, decide your layer of protection analysis, which is going to contain safeguards. So for these safeguards, I could go to my safeguard list and see all of the parameters, and then I can link this back to the Vertigo study where I do all of my SIL verification. So everything is completely tightly integrated, but it still has the advantage of separate studies that are linked together instead of doing everything in one monolithic database, which kind of handcuffs your ability to customize as you need to. So yeah, full life cycle from cradle to grave.
Okay, great. Is it possible to get a trial for this software?
Go to our commercial website, which is www.kenexis.com. We'll go to software, and let's say you want the SIS safety lifecycle. So this is our Vertigo tool. You go here to trial request and pricing information will take you to the bottom of the page. and you click on Vertigo trial request, fill out the form, hit submit, and you will get a 30-day trial. This request for a free trial is for whatever module you want. I showed you in this seminar, I showed you our Open-PHA software and our Vertigo SIS lifecycle management, but you could also look at our fire and gas mapping software, our auditing software, and that more advanced OpScope software too.
The Kenexis Integrated Safety Suite.
Yes.
What does it bring?
In the Kenexis Integrated Safety Suite, it's a collection of applications. So the applications that we have, and we license the applications one at a time. We can bundle all of them together for you if you would like and give you a discounted price, but that's something that happens. It's not a standard product, if you will. It's something that we do on demand because not every company wants everything because we do so many different things. I've already shown you the Open-PHA software. So the Open-PHA software right now, I showed it to you for commissioning, but this is what it looks like when you're doing HAZOPs and LOPAs. So that's one of the modules. And then I also showed you our Vertigo software, which is the SIS safety lifecycle, where you build your safety instrumented system design and run all of your SIL verification calculations on a loop-by-loop basis. So those are the most popular items. The third most popular item is called Arbor, which especially if you're doing SIL verification, you might run into a complex safety function. Let's say something like I have a fired heater where shutting off the fuel gas, I can either shut off a main header or I can shut off all of 6 individual valves. Well, there's no equation for that. So then you're going to want to use a fault tree, and we can link these fault trees to our software tool, our Vertigo software tool, or you could build a fault tree for any reason that you might want. So Arbor is another tool for fault tree analysis, which is a little bit more specialized. We have our Open bow tie software, which allows you to draw bow tie diagrams, which are a little bit more complex than your typical LOPA, because unlike a typical LOPA, a bow tie is going to consider multiple different consequences that can occur, whereas a LOPA only allows you to look at one consequence at a time. So our bow tie software allows you to not only, most bow tie software just draws a pretty picture for you that describes your risk scenario, whereas our bow tie software is fully quantitative and it allows you to run calculations also. Effigy, let me throw this up real quick, is our 3D fire and gas mapping software. So what we do is for a 3-dimensional facility, you can lay out your fire detectors and your gas detectors, and the software will calculate coverage targets. So if I wanted to know my fire geographic coverage, what you're looking at here is for these detectors that I've placed on the screen. At the elevation of interest, everywhere that's red, none of the fire detectors can see that. If it's yellow, one detector can see it. If it's green, 2 or more detectors can see that location. So that's kind of the process for fire detection. And we also do gas geographic coverage. So these green detectors, you'll see this is a green Open-PHA detector. Right there is a point detector of gas, and we can do both geographic coverage and also scenario coverage, which looks at all of the gas clouds and the wind directions and so on to determine what fraction of all the release scenarios that you can detect. So that's in the kit. That's another tool, it's not as popular because there are more people designing safety functions than designing fire and gas systems. So it's just a matter of the number of potential users. What I didn't show you, and I don't have an example here, is Open Audit. Basically looks just like Open-PHA. Let me open up Open-PHA again. So Open Audit is going to look very similar to this, except the worksheets are configured for the auditing process as opposed to a HAZOP process. And then finally, OpScope, basically a procedure management tool where you define procedures and then use a smartphone to follow along and execute the procedure as they're going on. So all of those things together are considered Kenexis Integrated Safety Suite, but you license one application at a time. And regardless of what you license, our Learning Center is available to you. So in the Learning Center, there are a bunch of available courses. These you're not going to see because they're internal to Kenexis, but everything with graphics you can see. So if you want to learn how to use the Vertigo software, you click here and you'll go into the training class for using Vertigo, which is our SIS design basis software. And you can see that there's going to be welcome to the Kenexis recorded lectures for how to use the software. There are going to be exercises and quizzes. There are going to be course documents that you could download. So it's kind of a full training. And all of the training for how to use the software is free. So let me go back to our inventory. So you'll see using Effigy, using Open-PHA, using Vertigo, they're free. But we also have courses on theory, like how to, safety requirement specifications. It goes into the standard, explains how you need to write safety requirement specifications. These are available in the premium paid version of the learning management system. So this kind of learning management system is kind of like the Netflix of process safety training, in that you pay to access the service, and once you access the service, all of the content that we have is available to you for whatever the duration of your license is. Thank you, everyone. I appreciate your time.
With that, we'll end today's webinar.